remember the symmetry. That's an attribute that we were supposed to wrap up yesterday. You can be symmetrical to the x-axis. You can be symmetrical to the y-axis. Well, you can't be, but a function can be symmetrical to the origin. Now, a function can only be these two categories because the first one, if you're symmetrical to the x-axis, guys, about the arrows. The arrows are like so important in the graph, and we don't really spend a lot of time on it. Okay, so end behavior, y'all, just describes the arrows. End behavior is what happens to the value of f of x as y or as x increases or decreases without a bound. So what we do not have here is, well, first of all, can you just kind of remind yourself that end behavior is always about the arrows on the graph. Always, 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 always. Now, what we're going to do, guys, is we are going to actually sketch a graph. Sketch it yourself, just the x and y axis. And then let's sketch a cubic function. Just remember a cubic function looks like that. Draw arrows on your cubic function because we're going to demonstrate how to write end behavior. Okay, so as we're looking at end behavior, we're always going to look at the negative infinity and the positive infinity, which is so easy to find. Negative infinity is always the arrow on the left side. Those two go together. Positive infinity is the one that's on the farthest right. So this is positive infinity, so that's going to match this. Okay, so as these values are getting towards the left of the graph, remember that's inputs, what is happening to the outputs here? Are the y values increasing or decreasing? Good, so we're going to write negative infinity. What about when the x values are getting higher over here in quadrant 1? What's happening to the y values? Increasing. So the way that we read this, as x approaches, so when you see that sideways arrow, it means approach. As x approaches negative infinity, f of x, or the outputs, approach negative infinity. As f of x approaches positive infinity, as x approaches positive infinity, f of x approaches positive infinity. So that is how we're going to start out with our end behavior here. Now let's go ahead and take a look at two different ways to find end behavior. So end behavior will either approach infinity, or it will approach one of these. What am I writing? Yes. So let's talk about when a graph approaches infinity. It's going to be very similar to this step up here. Here is my far left side arrow, that's negative infinity. So as x approaches negative infinity, what's happening to those y coordinates? They're decreasing, it's going down, so let's draw another negative infinity symbol. Here's your positive arrow. So x is going to approach positive infinity. What's happening to the outputs? Still positive infinity, good. Let's look at this instance down here. Here is my negative infinity symbol. So x is going to approach negative infinity. What's going on with those outputs, guys? Still negative infinity. Great answer. Yes, yes, yes. But look what happens when the x values increase over here. What's happening to these y coordinates? Yeah, it's still negative. Good job. So that's how we write it when we see that it's approaching infinity. Now, Over here, when it approaches an asymptote, or I should also have this because it could be more than one. Now, for this side of the paper, there's things that you need to understand. You have a lot of kind of asymptotes, lots of different kinds. We're just going to focus on horizontal and vertical asymptotes. I'm going to abbreviate. HA stands for horizontal asymptotes. Horizontal asymptotes can sometimes be crossed by a graph. Not every other ordered pair, like maybe once and then that's it. As in this problem right here. We'll talk about it. So horizontal asymptotes are like, okay, graph, you can cross me just this once, but then that's it, never ever again. And then you have vertical asymptotes, which never, ever, ever get crossed. If you cross a vertical asymptote, then a parallel universe just imploded because it's absolutely impossible. You cannot do it. Okay, so let's kind of talk about what's going on here. Asymptotes, guys, only occur when you have a square root or if you have some x in the denominator, because those are your restrictions. So the stuff that we talked about yesterday when we were saying what x could not equal makes weird looking graphs because it makes asymptotes. All right, so we actually have a horizontal asymptote right there. And it did cross it, the silly graph, but it only crossed it once. That's still okay. Guys, that is the x-axis, but what is that written as an equation? What is the equation of this line right here? Horizontal lines are y equals. What is y equal right here? That is correct. It is 0. When you write the asymptotes on your paper, it helps you write the end behavior. Speaking of end behavior, right underneath that asymptote is negative infinity. So let's go ahead and write x is approaching negative infinity. And then, what is f of x approaching? It's not going down like these other ones. It's getting closer and closer to this. Exactly. That's why we wrote it. Remember, f of x and y equals mean the same thing. Very good. Let's look at the other side. Let's look at positive infinity. So if you noticed, here's where the silly graph crossed the horizontal asymptote. It bumps up a little bit, but it's like, oh, no, no, no. There's a horizontal asymptote. I want to get close to it. So even on that side of the graph, what is it still approaching? Exactly. Good job. Okay. Let's look at this one. I'm going to zoom in a little. All right, look, guys. You actually have two. You do have a horizontal asymptote. Your horizontal asymptote is right here. And I'm going to tell you the equation of that line. That's y equals 3. It's right in between 4 and 2. But you're telling me the vertical one. What's in the what can x not equal in the denominator? That's it. That's the vertical asymptote. Every single time you're writing what x cannot equal in a denominator, you just identified a vertical asymptote. Those are exactly the same thing. Every single time in every single math class. So good job. So we have a horizontal asymptote here. We also have a vertical asymptote of x equals -1. Now, for this class, we are only focused on negative infinity and positive infinity, which is the arrows on the furthest most left and the furthest most right. Now, if you look at the graph, you have 2 arrows here and 2 arrows here. For us, just the furthest one to the left and the furthest one to the right. Now, remember, the furthest one to the left is always called Negative infinity. So as this graph is getting closer and closer to negative infinity, what is this approaching? You just wrote it. What is the graph approaching? 3. Yes, that's right. What about when it's approaching positive infinity? Same thing. Great job. Yes, yes, yes. Whoops. And that is end behavior.